Welcome to the Voiceware Tips and Tricks series. In this series, we're going to look at networking. We're going to look at different setups and installations and the different types of networking, ports, and IP addresses that you're going to want to open. This is designed to give someone who has not really installed a Voiceware system before some general knowledge on the networking requirements of SIP and the Voiceware system. So let's go ahead and dive in. The first thing we're going to do is to look at some of the different ports that are used by the Voiceware system and what they are, what they do, why they're open. So the first one we're going to look at is port 80. This is HTTP. This is for unsecured web browser access. This is a TCP protocol. And its cousin, 443, which is secured website access, or HTTPS. Both of these are TCP, and these are used to access the configurator and the browser console of the Voiceware system. So if you want to access the Voiceware system through a web browser, these are the two ports that you're going to need to have open. The next ports that we're going to look at are 5060 for SIP signaling. This is generally UDP. We also have 10,000 to 20,000 UDP for real-time protocol, aka voice. These also work in a relationship to set up SIP calls. That's what 5060 is. And then once the SIP call is set up, voice is passed in two directions using two ports within the 10,000 to 20,000 range. So without port 5060 open, SIP calls cannot set up. If you have 5060 open but you neglect the other port range, you can set up calls but you'll never get any audio. Port 8080, this is used in some special circumstances we'll talk here about in a minute regarding the property management system interfaces when you're using a hosted system. Port 123, this is a very old port in terms of networking. It's used to just do time updates. We use it specifically so that if you have a phone that's tied to a Voiceware system, that phone is usually told to go to the Voiceware system and check for what time you should display on the phone. We also have some optional ports. Sometimes you will have a PMS system set up through TCP/IP, and you'll need some additional ports to have open to have that communication on. In this example, I just used 5555 and 5556. Those are common ports, but you can really use anything above port 1024 as long as it's not already being used. So for example, don't use port 5060. That's going to cause you a lot of problems. Lastly, one port that you may know about is port 22 for SSH access. This is a TCP port, and that is not normally needed. The reason is that you can SSH into one of the Voiceware systems using port 443. There's a special translation we have on the back end that'll take that information, the SSH information, and translate that over the port 443. So port 22 is usually not open, and we highly recommend that it not be open. It's one of the hackers' favorite things to scan for and test for, to try and find open Linux systems to do whatever they want to do with them. So for that reason, usually port 22 is not open. If it is open, you must have a very strong whitelist engaged so that not anyone can access that port. And we'll talk about ACLs and whitelists here in just a few minutes. The next thing I want to do is we're going to look at a couple of different Voiceware installation types and how the networking differs depending on the type of installation that you have. So the first installation we're going to look at is a generic Series 2. It's not a hosted system, it's just an on-prem Series 2 system. And in this situation, you've been allowed to install on the customer's network, which means that the admin phones and your browser console users are all on the same network. This is good in some regard because the SIP phones here can communicate locally to the Voiceware system using ports 5060 in the 10,000 to 20,000 range, And you usually don't need to do anything special to the router because the router should allow all traffic that's internal on the network to just pass without restriction. So if the phone wants to talk to Voiceware or the Voiceware wants to send a call to the phone, the router should just let that happen because it's all happening on the internal network. Same with the browser console users. They're on the internal network and they're trying to access the browser console that's served up over here off of the Series 2. And that uses ports 443 and 80. And again, because it's all on the internal network, it should all pass without problem. The only thing that you're going to want to have set up in this router is remote access for ports 80 and 443. This will allow you at your office or us at the Phonesuite office to remotely access this system, which is extremely handy for change ads or for troubleshooting. Now, this is not technically required. The system will function without these ports 80 and 443 being open for access to the outside world. But it does tie our hands a bit when we're trying to troubleshoot or do a change ad. If you don't have access to the system, you can't really do too much. We recommend that you ask, if you're installing on the customer network, ask them to open these ports and ask them to set up an ACL for the Phonesuite IP address range, which you can get by calling us, or in addition to that, also whitelist the public IP of your office. That way, you have access, we have access, but some other random person on the internet is not going to be able to scan and see those ports are open and start poking around. Again, we're going to talk more about ACLs as we go through, but this will be a common thing that I'll remind you on, saying, hey, we'll talk about ACLs here in a minute, but you'll want to keep that in mind. ACLs are a really good idea in terms of security. The next installation we're going to look at is a little bit more complex, but a little bit more common. This is how most of our systems are installed if they're on-prem. You have two networks. The customer's network is over here, and the customer's network has the admin phones, the browser console users, aka the front desk computers, and all of their other equipment, printers, and etc. And that is a separate network that we're not allowed to install our equipment on. They've decided that for whatever reason that they don't want additional equipment on that network for security reasons on their part. And that's fine. This is very common. So what you'll end up doing is you'll build this secondary network, which is the Voiceware network. So what you'll end up doing is you'll need to source a router and your own switch and your own network equipment, and in the phone room build a separate logical network. This presents a few additional problems in terms of setting up the equipment properly. Because this admin phone is no longer on the same network as the Voiceware system, these networks, even though they're probably housed in the same physical building, and maybe they have public IP addresses which are very similar, they are still, in logical terms, separate networks and completely separate routing over the public internet. I mean, this Voiceware network is probably in the same building, but could also theoretically be in a building down the street or across the country. In terms of networking, it doesn't make any difference. So what this admin phone will do, when it wants to make a call, it's been programmed with the public IP address of this network. And so the phone will initiate a call, go out of their network, over the internet, and then down to our network over here. For that reason, we need to open up some additional ports to allow that traffic in. So as you saw before, we have 80 and 443. This is needed for the browser console access. Recall that this is a separate network, just like you at your office would be a separate network. And so if the browser console users need to access the browser console, they'll need ports 80 and 443 open so that that traffic can come through their network, over the internet, down into our network, and be pointed to the correct location. The phone is going to need ports 5060 and the 10,000 to 20,000 range. And also for time updates, port 123 will need to be open. And these ports need to be open in this router here for access from the customer's network and possibly from the Phonesuite network and your office network as well. Opening all these ports to all three networks, the customer's network, your office network, and Phonesuite's office network, allows us not only to troubleshoot by accessing the system on ports 443, but also allows additional troubleshooting of being able to set up a remote phone. So if the customer is having problems making calls to a particular number, for example, you could, if you've opened up all of these ports correctly, you could register a phone at your office to their system and make calls off their system to do troubleshooting and testing. And that's occasionally very helpful to do. So for those reasons, we recommend you open up all of these ports. And again, as I mentioned, use strong ACLs and whitelists, which we'll talk more about in depth here in just a moment. The other thing on this network that I really haven't talked about so far is the guest analog phone. Because it's an analog phone, it doesn't really apply to the network. It doesn't need extra ports open. It's a direct physical connection. So that exists, but not really. It doesn't matter in terms of networking. We don't care about it. The next setup that we have is even more complex, and this is a situation where you have a hosted Voiceware system and a proxy Voiceware Series 2 cabinet operating the analog phones. So there's a lot to unpack here, so let's take a look at what's going on. So as before, we have the customer's network here, which we're not allowed to install our equipment on, which is fine. But the admin phones and the browser console users are both on that network, so we need to care about that. Then we have the Voiceware network. This network is on site, and this network has a Series 2 operating in what's called proxy mode. Now the proxy mode, what that means is that we've turned this Voiceware system into a gateway, and that's all it's doing. It's not processing calls, it's not processing admin calls, it's not using the IVR system. All it's doing is passing off SIP to analog, and that's it. So we have the guest analog phones down here, but you could really think of this as a Voiceware manufactured gateway, because that's really all this is doing at this point. So the logic of the system is not here, it's up here in the AWS hosted cloud environment. So what happens here is that when this admin phone wants to make a call, let's say they want to call the local pizza place, they'll make a call and that call goes out through their network, over the internet, over through the firewall in AWS, down to the hosted system in AWS, and this is where Voiceware resides. This is the main controller, so that this is the system that will control the inbound, outbound calling and everything else. So your call to the pizza place will go down through here, up here, to the Voiceware instance. It may have SIP trunks, and in fact, it has to have SIP trunks. There's no other options here. And so that call will get processed through Voiceware and then routed out the SIP trunks, which will go down through the internet again, down over to your SIP trunk provider, and then connected out to the telcos and finally to your destination. So you'll notice here that an admin call out to the pizza place doesn't involve the Voiceware network down here because we didn't call an analog room phone. So this system doesn't need to be involved. The path is through the customer's network, through the internet, into AWS, through AWS, back out to the internet, down to your SIP trunk provider. If the admin phone wants to call a guest room, our path changes a little bit. We still go out through the customer network, obviously, through the internet, through into AWS. AWS sees that this is a call for the guest room phone, so it knows, okay, I need to send that down to the Voiceware system or the proxy gateway. So it's going to go down through to the internet, down into the router that you have for your Voiceware network on site, and then that will get translated out to the Voiceware system. It'll know what to do with it and then connect the call to the guest analog phone. So as you notice here, we have a lot of routers involved. We have the customer router here, which we don't have access to, and that's usually fine. We have the AWS router called a security group, and we have the router here on your local network. Both of these routers, the AWS router and the router here on your local network, are both routers you control, and both of them need to have the ports 80 and 443 open. This will allow an internet user, aka us at the factory or you at your office, to be able to access the configuration side of the Voiceware instance here, or the configuration side of the Voiceware system here, in case you need to make changes. Ports 5060 and 10,000 to 20,000, those need to be open in both routers, because of course SIP calls from the admin side need to go into Voiceware. Also, when a guest room is called, that call needs to go out from the Voiceware instance here and down to the proxy gateway. So that's done over SIP protocols, of course. So 5060, 10,000 to 20,000. Port 123, this needs to be open here so that admin phones here can ask Voiceware for its time. Technically, it's not probably needed down here on the Voiceware network if this is just a proxy, because the admin phones are going to be asking the Voiceware instance, the prime Voiceware instance here for their time. They're not going to be asking the proxy gateway for their time updates. And then port 8080. This is the first time we've seen this, and this is a port used for the property management system interface. So one thing not pictured here, because I ran out of room, is the property management system. You can connect that via a serial cable to this gateway. So not only is this Voiceware proxy a gateway for your analog rooms, it's also a gateway for your PMS connection. So you would connect the PMS serial cables to this Voiceware system here, and then it would translate the serial connection over to an IP style connection and send that information, for example, a check-in or a checkout. That information would get sent to this box that would then translate it and ping that up back to the prime Voiceware instance, because this prime Voiceware instance really it's the one that needs to know about check-in, checkouts, name changes, room status information, things like that. So that's the connection there, is over port 8080. We also have the SIP trunk provider here. We don't control any of their firewall. They're just a resource on the internet, so they're just pictured here. This is an example of an AWS security group, and this is just for reference. This is not set up perfectly. There are no ACLs set up on this example, which we'll talk about here in just a moment. But I wanted to show you just what it would look like on the AWS side if you were setting this up. The interface, I think, is fairly straightforward. So for example, on AWS, if you want to open HTTP, you just select that from the list. It knows what protocol it is. It knows what port it is. And then you tell it which IP range you want to have access to it. Now, in this case, the 0.0.0.0 is AWS shorthand for everyone in the world. So anyone, if they knew the IP address of your system, could access it on HTTP and HTTPS. And sometimes that's necessary. Sometimes you have resources out there that need to contact your system whose IP address, public IP addresses change. So occasionally this is needed to be left wide open. But it is best practice to be more restrictive. So as you see here, this SSH, we do not ever want that open to the world. That is an invitation to hackers the world over to start pounding on your system. So in this case, we've restricted this highly to just this single IP range, or excuse me, this single individual IP. So there is only one IP in the entire world that can access this system via SSH. Everyone else will have their packets rejected. The next setup that we have here is if we were using gateways. And this is going to be very similar to our proxy installation with just a few caveats. So again, you have your admin network here and with your admin phone, your customer network with your admin phone. And it will make communication out when it wants to make a call. It's going to communicate out through the customer's network over the internet, up through the AWS firewall into your AWS instance, just as before. A call to the guest room phone would go through here, then go back down through the internet, through the router, and then to your gateway, whichever gateway you're using here, and then that's translated to analog and connected to your analog station. Uh, Notice here we don't have a Voiceware server. That's because we're using third-party gateways. In that case, we don't have the option to allow Voiceware because it doesn't exist here on the internal network to translate the PMS connections. So what you would need to do is if you do have a serial interface for your PMS, you would need to use a serial to TCP converter, something like an iPocket, or there are other devices that accomplish the same thing. And what this will do is this is a strict translation from serial to TCP. And so we have additional ports, and these ports could be anything. I've listed them as 5555 and 5556, and you're certainly more than welcome to use those, but it really can be anything that's not already used. I mean, they could be 7777, for example. You just need to decide on something. But once you decide, and this is something you'll just have to make a decision on, you'll need to make sure that those ports get open in the AWS security group, because those are not open by default. 5555 and 5556 are not ones that we open. So whatever you decide to use, because that's the system here is going to, when it gets a PMS connection message, let's say a check-in, it's going to take that, convert it from serial to TCP, and then it's going to send it out to the IP address of your Voiceware system up here. And if that the ports you're using aren't open in your security group, that traffic gets up to here and gets blocked, and Voiceware never sees it. So your check-ins, check-outs will never hit your system. So you'll need to find those ports. You'll need to open those ports in the AWS firewall. Otherwise, this picture is identical to what we saw before, and the communication is also identical to what we've described thus far. There's one additional thing, though, that complicates things just a bit. Voiceware itself has a firewall built in, and we've not talked about it thus far because it's not been relevant. Going back to our picture here, if I want to make a call from this admin phone, I need to have the connection not blocked by this router, which it usually won't be, but then it's passed over the internet, and this connection needs to be allowed here, which I can do by opening 5060 and the 10,000 to 20,000. And then that connection comes in to Voiceware. And I've not mentioned you need to open up any ports here yet, because all of these common ports, 80, 443, 5060, this 10,000, 20,000 range, 123, those are open by default in the Voiceware firewall. So I've not mentioned it yet because you don't need to do anything. Voiceware understands that it's a SIP system, and thus has been pre-programmed to allow connections in on common ports, 443, 50, 60, etc. So you don't need to manually open those on Voiceware systems. However, 5555 and 5556 are not common ports, and those are blocked on the Voiceware system. So even if you open 5555 on the security group here, it still won't work until you tell Voiceware specifically to allow those ports in. So these commands here are how you do that. These are how you would open up a port on the Voiceware firewall. These need to be entered from the SSH command line. So there's not a GUI interface for this. You need to SSH into your Voiceware system. You need to open up these ports. So this is how you do this. You would issue these commands. So for example, you have the sudo iptables -i trusted -p tcp -s, and that's your IP address, and then your port number and accept. So this is the base command. This is what it looks like with information added. So your IP here would be replaced by something that looks like this, not actually 1.2.3.4, but whatever public IP address your Voiceware network is at. And then your port that you're using. Again, I'm giving the example 5555, but you can use anything. Once you issue this command, then you need to issue this command, which will save your changes. And you can issue, like for example, if you're opening 2 ports, you'll want to issue this command twice, the same IP both times, but different port numbers. Then you can issue this command once to save it. If you issue this command and then save it, and then want to issue this command again for a different port, you'll need to save again, but that's fine. You're not going to break anything by doing multiple saves. Even if you don't make any changes and want to run this command twice just to be on the safe side, you're not going to break anything. It'll just save and realize, okay, there were no changes made, but I'll tell you it was saved anyways. The last thing I'll mention here is this can be a little bit complex, and I realize that not everyone is comfortable using SSH command line interfaces to type in Linux commands into a system, and that's fine. If you need help with this, please contact our support department, and we will be more than happy to walk you through this or to just go ahead and issue the commands for you, because these need to be done one time. Once you agree upon the ports, as long as they don't change and your public IP never changes, these need to be issued exactly once. We save it, and then you're fine for the rest of the system's life, and you don't need to go in and do this a second time. The last thing I want to talk about here, as promised, is access control lists. Access control lists are one of the best things you can do in terms of security. And what it is, it's just a simple list of people who are allowed to access your system. And by people, we reference that by IP addresses. So for example here, we have a little setup, and let's say we have 3 different people trying to access your system. We have someone from the approved IP address of 1.2.3.4, we have someone else from the approved IP of 5.6.7.8, and then we have somebody else, some other person on the internet who we don't know and don't really trust. So what we do is we go into either the AWS system, which has the ACLs, or if this network over here, let's say this is your on-premise network, and this is your physical router that you've bought and installed at the site. Most routers worth their salt have an ACL concept built in. And in fact, if your router that you're trying to use doesn't have ACLs, that's a pretty good sign that you shouldn't be using it. It is not really a business class router. So you'll want to go through your router's documentation and find out where ACLs are set up and how those are actually applied. Routers are all very different, as I'm sure you're aware, and I can't explain how to set those up in each router. But once you set those up, you just give the router a list of these IPs. So you say, okay, this IP and this IP are allowed to pass traffic. So if you see traffic from those IPs, they're good, but anyone else by default is blocked. So what will happen here is if we get a request in from this IP, the router is going to look at your ACL list and it's going to go, okay, this IP 1.2.3.4 is on the list, so I'm going to go ahead and pass that traffic to the Voiceware instance, in this case, if this is AWS, or your Voiceware system, your Voiceware on-prem system. And this guy's happy. The next thing that happens is we get a request from this guy, and again, we're going to look and we're going to see, okay, they're on the list, we'll go ahead and pass their traffic, and he's happy, he's in. But then all of a sudden we get a request from somebody we don't know. So again, we look at the list and we go, you know what, that IP, that 7.8.5.4 or whatever it happens to be, is not on our list. So we're just going to go ahead and take that traffic, we're just going to null route it. And what happens here is they don't get a response. They just send traffic up and it never comes back. And that's exactly what you want, because hackers and scanner bots will look and see if there's any response. And you want it to look to them like the system they just tried to access, the public IP they just tried to ping, is turned off. Everything's unplugged. There's no equipment on to respond to them. That's what you want it to look like, so that they say, oh, well, I'm not getting any response. Maybe there's really nothing there. And we'll go ahead and move on to different systems that are at least responding to us. So that's ACLs in a nutshell. And again, their setup can be a bit different depending on what equipment you're using. And I can't describe exactly how ACLs are set up in every router and every device that's out there. But they are definitely something you want to use. Now, the only downside to ACLs is that you have to have a list of the public IPs that are going to be accessing your system. And if those are all static IPs, that's great. They don't change. That's what static means. And you can add them to your ACLs. However, the real world is sometimes a little bit more complex. Uh, Occasionally, you will have the request that somebody is working from home and they have a phone at their house that they need to have work off of your system. And they, at their house, they have customer internet, and generic customer internet does not generally include a static IP address. Their public IP address will be assigned and can be reassigned at will by their internet service provider. And that adds some complexity and may mean that you can't use ACLs, because if their IP address changes and you've whitelisted the old IP but not their new one, then they're all of a sudden their phone's not working and they're quite upset. And sometimes that can happen frequently. Sometimes IP addresses can change, weekly or even daily. It just depends on the service provider. You can try and ask the service provider for a range of IPs that they would switch between, but that is going to be a difficult thing to get in terms. Generally, your average customer service rep is not going to be able to give you that list. Let me just put it that way. So in that case, if you have a remote user whose IP address is shifting and you don't know what it is, you can't pin it down, sometimes your only option is to leave stuff open. And that's not ideal, but there are additional security parameters, of course, in the Voiceware system that make sure that people who are trying to, for example, register a phone that doesn't exist on the system, those people will, of course, be rejected, and that will not be connected. We also have a process on the Voiceware system running called fail to ban. And what this does is it automatically blacklists people who attempt to register a phone or access the browser or the web GUI too many times and fail within a certain amount of time. So if you do have a scanner bot out there and you've had to leave your system open, the scanner bot will not be able to try indefinitely on the system. What will happen is they will be given a certain amount of tries. Voiceware will look and say at some point, okay, you've tried too many times within this time frame. I'm going to go ahead and add your IP specifically to a blacklist. And then that person cannot access the system again. And that will help prevent hackers from, again, scanning your system and just pounding on it indefinitely. The last concept I want to talk about is port translation. Port translation is another security thing that can be done to help disguise common ports so that they're not as easily found. This isn't amazing security, but it can help prevent some of the more common scanning bots that we see out there. So what happens here is you tell the firewall that when you get a request on one port to go ahead and translate it to a different port before you pass it internally. And so what's very common to see set up is a translation like this. We'll translate 59850 and we'll translate that to port 443 internally. And so what happens here is an outside user would need to know that port, and they would need to make a request to your system using that port number. And then when they do that, the router will translate to 443 and allow you access. So you would put this in your web browser and you would say, okay, I want to go to this IP address, colon this port, and then you would get access to the HTTPS, aka the web browser or the configuration web page that's hosted off the Voiceware server. This again is designed to help secure your system a little bit. If you do this port translation and leave straight 443 closed, then a scanner bot that's scanning for open web pages will scan 443 or 80. They'll not see anything there and they'll go on. Now, if someone is attacking your system specifically, there's nothing to stop them from scanning all ports and eventually finding this. But it's designed, again, not as great security, but as just an additional layer to help prevent some of the more common scanning bots and the lazy people who are just trying to find something easy. They're not going to see it on your system, so hopefully they'll go bother someone else. That is the end for our networking video. So a lot of information we covered. Please feel free to, obviously, you could pause, stop, and go back and rewind and watch this again. And this is designed to give you a general overview of the networking requirements that a Voiceware system has, the best practices for setting them up, and some of the common scenarios that you have and the different networking architectures that are seen out there. Uh, do keep in mind we have a few other tips and tricks videos available on our YouTube channel. Thank you very much for watching.